Good morning, gentlemen, and happy Monday. Today is Monday, May the 18th, and today we are going to start a new unit. Now, just so that you are aware, on Wednesday, May the 20th, we are going to have a review activity of waves and specifically of the behavior of light. And so make sure that you are prepared for that. Make sure that you get the rest of your homework assignments in as early as possible so that I can get the answer key out to you so that you can make sure that you know what you're doing for Wednesday's activity. Now, today we're going to start a new unit, and this one is entitled Geometric Optics. All right, and this is in my opinion, a very cool thing, and the founder really of this is once again Sir Joseph Newton. All right, he wrote a book way back when called Optics, and this is essentially was the beginning of the study of geometric optics. Now, what this is all about is the formation of images. All right, what exactly is an image? And believe it or not, there are multiple kinds. And how many different ways can we form an image? And believe it or not, there are multiple ways to form images. So images in and of themselves are simply formed when light rays originating from the same point. So your toes, a tennis ball, whatever object it happens to be that you're looking at its image. The two light rays originate on a same point or from the same point on a given surface, whether that's you or a tennis ball or your dog or whatever. And they then intersect on a surface, or at least appear to intersect. All right. Now, there are differences between the various kinds of images. All right. They either intersect on a surface or they appear to intersect on a surface. And this is the difference between what we call a real image and what we call a virtual image. All right. Now, I'm going to take my image and move it up to the corner here because it's a little bit it'll be a little bit less distracting as the rest of this video goes on. And I'm going to give you diagrams to show you all of this. I'm hoping actually to scan some more stuff into the computer and send you a picture of various ways that we can form images. But I haven't gotten to that point yet, so just hang on. But they're coming, I promise. So what is a real image? All right, well, a real image is formed when the rays of light from a common point, so from one point, pass through an optical system. All right, now an optical system is a mirror or a lens. All right, a mirror or a lens. So they pass through an optical system that causes them to converge and intersect on a surface. Okay, now the image itself really exists. All right, and therefore it can be projected. So this is generally formed by different kinds of lenses. Think about the lens in a camera. All right, it forms an image on a piece of film or digitally in a different way. As opposed to a projector. All right, in our classroom, for example, which actually projects the image onto the smartboard. All right. But an image formed through an optical system that does this is inverted. In other words, it's upside down. And so most cameras and projectors and that sort of thing actually have to use two different lenses to first invert the lens and then invert the image and then revert the image back to its original form. All right. So a real image is something that really does exist, so it can be projected onto a screen, but it does form upside down, inverted. Now, So again, think about a movie projector or the projector for the smartboard. Think about the lens on a camera, right? Even think about the lens in your eye. If you've studied a little bit of biology, you know that your retina actually perceives everything upside down, and it's up to your brain to actually revert it to its actual uh, orientation. Now, the other kind of image is the one that you find, for example, in a flat mirror. All right, and this is called a virtual image. All right, this image is very, very different because the image itself does not exist. It exists only inside the imaginary spot in the mirror. All right, you can't touch it, you can't project it. An image produced by a mirror is not able to be projected onto a screen or anything along those lines. All right, so by definition, a virtual image is formed when light rays from a common point pass through an optical system that causes them to diverge and appear, all right, and this is the key, appear to originate from a point. They don't really, because that point doesn't exist, right? But they appear to originate from a point. Now, what this means is that the image does not exist, okay? It's not real. It exists only inside the mirror, which is a virtual reality, all right? This is where the term originates from. And because it doesn't exist, it can't be projected outward onto a screen or a smartboard or anything along those lines. Another difference between real and virtual images is that real images are inverted, whereas virtual images are erect. Now that means that simply that they're right side up, that if you're looking at your image in a mirror, your head's on top and your feet are on the bottom, unless you're doing a handstand. Okay, so what does all of this mean? Let's start with the simplest of cases. Let's talk about an image which is going to be produced by a flat mirror by the process of reflection. Now, you've all seen your own image in a mirror, so you know what it looks like, all right? But how does it actually form? Well, this is a great little diagram to illustrate just how you might see your own image in a mirror. Now, let's say you can see the mirror, it's right here in the middle, and the object is the person, and then the image sits inside the mirror. And there's a couple of things I want you to notice here. We're going to concentrate on 2 points, the top of the guy's head and his toes. All right? A light ray coming from the top of his head moves toward the mirror and is reflected back, angle of incidence equals angle of reflection, into his eye, all right? And so therefore, we can see the top of his head, or he can see the top of his own head. But, oh no. Crying out loud. But if you followed that image, or that the blue ray of light, after it's actually reflected, if you follow the reflected ray backward into the mirror, and that's what the dotted blue line, right? So the light ray comes here, it hits the mirror, it's then reflected into the eye. But if I follow that reflected ray backward, it eventually reaches this point here. Now, this dotted line represents a ray of light that doesn't exist, but it's the same length as the reflected ray. Now, the same thing is done with the image from the toes. That ray of light will come from the guy's toes. It will strike the mirror, be reflected, angle of incidence equals the angle of reflection, and it'll be reflected right back up into his eyes. And that's represented by the red rays of light here. In this case, this is the incident ray, this is the reflected ray. And if I follow the reflected ray backward, it reaches a point here. And so the light appears to the person standing in front of the mirror, the light ray appears to be coming from here. The blue light ray appears to be coming from here, right? But in reality, they're not. They're coming from his own head and his own toes, right? And so that's what makes this a virtual image. The image itself is erect, meaning that his head is still on top and his feet are still on the bottom. And it's exactly the same size as the object being a person. The image is exactly the same size as you are. So when you look in a flat mirror in your bathroom in the morning while you're shaving or whatever, that is your image is exactly the same size as you are. In addition, the image is exactly as far behind the mirror as the object is in front of the mirror. And that's illustrated by the D's here and here. The distance between the mirror and the guy's toe is the same, whether you're looking at the object or the virtual image inside. The biggest difference between the virtual image and the object is that the image is perverted, laterally reversed, all right? Meaning that if you raise your right hand, okay, your image raises his left hand, all right? And so, if you part your hair on the right side, your image is parting his hair on the left side, and so on and so on and so on. All right, so the image itself is laterally reversed, okay? So that is the idea of an image formed by reflection in a flat mirror. Now, interestingly enough, mirrors don't always have to be flat. We can actually form images using mirrors that are curved. But this brings us to another divergence in our discussion, in that the mirrors themselves can be curved inward or they can be curved outward. Regardless of which kind of mirror you're using, all right, whether you're in a fun house or looking at your own reflection in a spoon, you ever done that? You're dealing with what we call a spherical mirror, all right? Whether it's curved inward or curved outward, we still call it a spherical mirror. And the reflecting surface is simply a small portion of a sphere, all right? Imagine a ball. All right, imagine that this is a mirror, and you simply cut out this little space, this little spot, and you pull it off, and there it is. All right, and if you are going into the curve, like so, all right, that is would be a concave mirror, and if you turn it the other way, you're going toward what we call a convex mirror. But regardless of whether you're using concave or convex, the mirror itself is just a small piece of a sphere. Now, a couple of terms that we have to define, and these will become much more important tomorrow when we apply a little math to them. But the first is this idea of C, the center of curvature, okay? And so if the mirror was originally part of a perfectly spherical glass ball, and you cut off a little piece of it, the center of where the sphere would be is called the center of curvature. All right, right in the middle of where the ball is, all right, that would be the center of curvature. Now, that's not inside the mirror. If the mirror is here, the curved mirror is here, the center of curvature is going to be like right here where the tip of my index finger is. Okay, so that's the center of curvature. The line that connects the center of curvature and the vertex of the sphere, meaning the dead middle of the mirror, is called the principal axis. And the vertex is abbreviated with a capital V. All right, so we get the center of curvature and the vertex and the principal axis, which is the line that connects those 2 points. The focal point or focus, abbreviated with a capital F, is located on the principal axis halfway between the center of curvature and the vertex. All right. So in other words, C equals 2 times F. Okay. C equals 2 times F. Now, as I said, there are 2 different kinds of spherical mirrors. And so let's take a look at each one of them, and then we'll call it a day. All right. So in terms of the first kind of mirror, this is what we call a concave mirror. And it looks something like this. All right. Now, I could not find an image on the interweb that actually showed where the center of curvature would be. But in this particular case, we know since this is the focal point, the center of curvature is going to be twice that distance. So C is going to be out here somewhere, maybe there. All right. That looks to be a little far out, actually, based on this diagram, but you get the idea. Now, why do we call this the focal point? Well, we start with a point on the object, and the object, we're just going to keep it simple and keep it as an arrow. All right, notice the first way. Oh, actually, let's go through the other stuff. Here's the principal axis drawn as a dotted green line. This point right here would be the vertex, right there. This is point F, the focal point, and here's C, twice as far away. Now, two rays of light, both emanating from the top of the arrow. One is going to travel toward the mirror parallel to the principal axis, be reflected, again, angle of incidence, right? We'd have to draw a normal line in here, like so, but the angle of incidence and the angle of reflection are the same. And so the reflected ray comes down and goes off this way. A second ray of light, drawn directly through the focal point, will then be reflected so that the reflected ray is parallel to the principal axis. Okay? Where those two objects meet is the image. Okay? Now, because the image does not exist inside the mirror, but rather outside the mirror, it can be projected. And so therefore, it is a real image. But notice that it's inverted. It's upside down. Go to your kitchen, pull out a spoon, hold the spoon, I don't know, a foot or so in front of your nose, and look at your image. It's upside down. All right. Now, a spoon's not a perfectly spherical mirror, but it's close enough. It works. Go, seriously, pause the video right now and go do that. You'll see yourself in the spoon upside down and a little bit distorted. You're not exactly the same size and everything else. You'll you'll be a little bit smaller. All right. But this is the way that we form an image by reflection in what we call a concave mirror. All right. The light rays converge and we form a real image. Now, on the other hand, what if we were to use the other side of the spoon, not the hollow side, but the curved outward side? Well, in that case, we're looking at something let's try that sentence again. We're looking at something that we would refer to as a convex mirror here. And this is an image from a different set of slides. And this one does include the center of curvature. So here's the sphere. All right, if we were to continue this all the way around, it would be this. Here's the sphere. So here's the center of curvature. The focal point is halfway between the center of curvature and the vertex, which would be located here. Now, we're going to start with our object way out here, and we're going to draw the same two rays of light from the top of the arrow. The first one travels parallel to the principal axis, and it will be reflected. But notice that it's not being reflected toward the principal axis, but rather, in this case, away, because now the normal line goes off like so. Okay. The other ray of light travels directly to the focal point. All right. And so if I aim it right at this, actually, I just noticed this is wrong. All right. Well, this, I just realized that. But this ray of light should be aimed toward the focal point. Let's try this again. I'm going to actually start at the focal point and work my way. Nope, I got to do this way. All right, that's not perfectly straight, but it's close enough. So in this case, the ray hits the mirror here, and it's actually reflected right back up. Now this arrow, notice it's pointing the opposite direction. That's because the ray is now being reflected right back to the object. Now, if you then extend that line backward into the mirror, you'll find that the two dotted lines where they cross is the where the object, or I'm sorry, the image is going to appear. So I know that this is not quite as pretty as you might want it to be, but in any event, where they ordinarily would cross, that is the where the image would be. So the yellow arrow here, this thing is the image. Okay. So we got the object on the outside and the image on the inside. All right. This is why I tried to use diagrams, because I knew that drawing this thing would be an absolute mess. Anyway, the convex mirror causes light rays to diverge. And because the image exists only inside the mirror, it is a virtual image. All right. The image itself, notice it's erect, right side up, but it does not exist in the real world. It only exists inside the mirror. Okay. That, my friends, is the end of our introduction here. I hope I haven't confused you too much with this mess, but hopefully you get the idea. Again, I will be sending you images of the various scenarios that we can work with, and tomorrow we'll specifically talk more about these curved mirrors. All right, boys, happy Monday. I will see you soon.